My name is Pete Lace. I'm the AVP of Product Management. And little housekeeping rules. If you just joined, please go ahead and mute yourself. We do hear, I do hear a few voices in the background, but nonetheless, happy March to all. And for this month here in the monthly product focus training, what we're going to do is we're going to start wide, and we're going to talk about give you a refresh on our flex connectors, the entire family, if you will, high level view, and then Mr. Tubbs is going to whittle that down into our one action family, and then he'll go even deeper into a new product introduction within that one action family, and that is our FH81. So without further ado, Mr. Tubbs, if you could please get started with the presentation. Thank you.
Thank you, Pete. I take it everyone can hear me. So everyone, thank you. We appreciate your time today. So like Pete said, we're going to be going wide. So I hope you 4 hours worth of your time, but no. We're going to kind of take it wide to kind of show a little bit of kind of where we are, where Hirose is with the whole flex circuit type lineup on there. And like you said, we'll get the more, what, Pete?
Oh, nothing from my side, Chris.
Okay, sorry, I thought somebody was asking a question. So,
yeah, there's a few folks who have not muted themselves yet. Please, please do so. Sorry about that.
Oh, no worries. So, and then we'll get down deeper into the actual product itself on the FH81. So, like Pete mentioned that, so Hirose has got like, and this is 756 connectors. It's not 756 series. So it's actually quite a large offering of flex connectors. And I've said a lot of this time, or I've said it before, that, you know, they're all the same, but yet they're all different at the same time. And it's that difference that actually sets Hirose apart on a lot of stuff, that we do have all of these different variations on it. And so almost just for about just any given app or a customer need or a want, we probably flex circuit that's going to, or maybe more, chances are there's going to be, you know, 2 or 3 really good options that they could go with. So our connectors, the flex circuit Hirose stuff is broken into kind of 2 groups right now. So it's more of our traditional flex series, both the front flip and the back flip. And those ones are where you would, the operator, the assembly person would actually have to open the actuator on them, insert the FPC or FFC, and then close that actuator. And the only difference between front flip and back flip is that, just as you can kind of see there, there's the front actuators in the front for a front flip, and then the one in the back is the back flip, pretty straightforward. The benefit to the back flip style is, I guess, years ago that there was issues that, and it might have had something to do more or less with the way flex circuits were designed or the way they were made, you know, 25, you know, years ago, that I guess if the flex was pulled in the upward direction on it, it could open the connector on it. So probably, you know, back in the early 2000s, 2004, 2005, we started seeing a lot of advent of backflip style. So the backflip, the big advantage there is that you can pick up on the flex circuit on the front, and it doesn't, all what it does is push against rigid housing. And there's no way for the flex to actually undo the actuator on it. But the amount of instances that we had, or, you know, it was negligible at best. So Hirose introduced, so then it kind of segues into our one action, where instead of having to open the actuator or anything, it is just one action. You take the flex circuit and it goes right in through the slot in the front of the connector. It kind of clicks into place and it's done. And now you can still get it open. You just have to open, there is an actuator on it. You just have to lift the actuator up and kind of wiggle the flex out. And it's got advantages too. It's very fast. It's very simple. It can be done with automatic assembly onto it. So some of the stuff here are conventional versus a one action style, like I was saying, where you got to open the actuator, insert the FPC, FFC, then the actuator's got to be closed on it. And this, I mean, for the most part, it works just fine on it. But there's 3 steps involved with it. And sometimes if the assembly person didn't get the flex in right, and maybe it's skewed on the pads, and it had some issues with it, but by and large, it was, it's a pretty reliable method onto it. The one action, the actuator comes in the closed position. So once it goes through reflow, it's ready to be terminated, so to speak. And all what the assembly person or the robot has got to do is just insert the flex in through the side and until it clicks in, and it's done at that. So it reduces the assembly process by 2/3 onto it. So it saves time, and it's not going to allow anything to where the flex can get skewed on the pads or anything. It's only going to go in kind of one way on that. So kind of delving deeper into our one action stuff, how it works. Again, I said it's one step, insert and it's locked, kind of does it on its own. But when you take the flex circuit and you actually put it in, now there's got to be notches on the flex circuit, but that flex circuit will kind of push the locking mechanism out of the way. It kind of pushes it up, and then when it gets in there, those locking tabs or those hooks drop down into place, and it flex into the connector itself, and it keeps it from coming out. So it's very, very fast. It's very secure on it, very foolproof on it. There's also some other benefits to it. So in a traditional, like say in this one here with a vertical flip type, if you've got other components or if the customer's got other components on the board, it might be difficult depending on how tall those are. And the one action would kind of get around that, where all what you got to do is just insert the flex. You don't actually have to operate that actuator. And all flex connectors, I mean, they all get connected once. But then, and so somebody might argue on this, it's like, well, now it's going to be harder if you got to get the thing off. Well, yeah, it's true. But like I said, all flex circuits have got to be mated once to begin with. But the vast majority of them, once they're mated, that's kind of where that flex lives for the rest of the device's life. And sometimes display has got to be changed out or it's broken, but the offset in, having to unmate a one action type in this, it's not difficult. You would just the customer would need a hook or a tool or something to kind of push the actuator open and then relatch it. But it's really not all that, it's not all that big of a deal on that. Other benefits on this again was years ago that there was a lot of actuator breakage because assembly workers would want to pick the actuator up in the middle of the actuator instead of like maybe onto it. That used to be kind of an issue. Sometimes there was breakage during shipping, it happened, but it was rare. But it does allow that super fast, you're dealing with only one step on this. So it's going down from maybe 3 seconds down to 1. And you can, like I said earlier, it can be on our one action, can be used with automatic assembly. And they're also, most of them are, very well suited for a lot of small, like wearable devices or very tiny handheld devices, stuff like that they're going to play well into those applications. So and this kind of gets back into some of the width or the breadth of Hirose stuff. Instead of just having one flex connector that's one action, we've got about 8 of them, I believe, right now. So this kind of this is kind of going from left to right, like pitch to largest pitch, and there's another slide to this, but so we kind of start off at FH81, at 1.75 millimeter pitch, which is utterly amazing. I mean, most of you have seen like 0.5 pitch, and I mean, it's really kind of hard to see it at 0.5, but going down into 1.75, it's almost like you can't even see the space between the traces. It's so compact and so narrow on there. But so we've got this number of different connectors, you know, FH67, 82, 62, 72s. They're kind of being go by, again, this is where we got different heights on these, different depths. The pitch is going to be the kind of the deciding factor on a lot of these things, or it's going to be the place where most customers are going to be looking at first, and then they're going to maybe start looking at, you know, the physical envelope of the connector. You know, I got to get it into this space. What do you got that fits this? So Hirose typically will have stuff that kind of will, you know, maybe they've got constraint and it's going to, you know, maybe they want to use 0.5, but they're space constrained and they've got to go to one of the smaller pitches. So that's kind of what it's going to have to be. But moving on, so FH63, S 0.5, and also the 67, and then on to the 81. And you can see they're much more common 0.5 pitch type connectors. They handle more current, they're bigger, there's bigger spacing on them. One key point here, like FH63 and 67 are kind of complementary connectors, that they both share the same flex layout, and that the 67 is basically the vertical style of 63S on there. So again, these two slides were just showing, you know, we've got a number of different one action locks to pretty much, you know, go into any application on that. This next slide is, and Hirose has made probably hundreds of these, but this is kind of what we call our door opener slides. So the product marketing teams have gone in, and like this one here happens to be for endoscopy video processor. So they'll go in and go, gee, what makes an endoscopy video processor work and everything? So then they'll kind of start doing a tear down of it, and then they go, what Hirose connectors can we get into that space? And so as you can see kind of here, some of the board to wire power supply stuff, you know, we got DF63s, DF60s, DF33s. And then on some more of the memory board and the front panel connection, we're getting into some of our, you know, like FH62, FH63Ss. So some of these, and if you need something to go into a customer to kind of pitch these, please tell us. We probably have a door opener. So the good of these door opener presentations is that they're just not, it's just not going to show you like flex circuits. It's going to allow you to actually push or promote, you know, maybe one or two or maybe more of a Hirose product into that design onto it to pick up the design win with it. Here's another one, proposal for smartwatch. You know, everything has got like a display. There's antenna type stuff, sensors, button, battery connections in here. And here kind of we're just maybe showcasing more FH62 and our FH72 series that would be kind of suited for a smartwatch type application. Some of our competitive analysis is here. I mean, I'll be honest, you know, Hirose is not the only company that offers a connector like this, but we do have, you know, everything in green here kind of is a, you know, like a kudos to Hirose that we've got a little bit more than other companies. And so it adds more variety, and that variety again gives you more opportunity to go, hey, Hirose's got this type of connector for it. It just might work here. So we got pitch, we got some more height options on there, contact, bottom, and dual. We've got bottom, top, and dual contacts on there. And the dual contact is an interesting one because it used to be where connectors, depending on how the traces came into the flex or to the connector, you had to have those traces oriented properly, whether if it was a top or bottom on there. And so if everything was facing upwards, then, you know, you had to have a top contact. And if the traces were coming in facing, or the connector was a bottom contact, the traces had to be facing down toward the PCB to make contact. In a dual style, you don't really need that. Basically, it can kind of come in either way, up or down, and the connector is going to work, which allows a lot more flexibility on the customer side because they don't have to kind of design or work around that. So getting on to our connector of the day here, du jour, FH81s. So FH81 is a 0.5, so it's going to be a larger pitch. It's 1 millimeter height, so it's very, very low. It is one action, and it is top and bottom. And again, the benefit there, as you can see here on the left-hand photo, the connector on the left-hand side is where the flex would be in a top contact orientation, and then the one on the right-hand side would be more where it would come in onto a bottom. And years ago, we actually had to have connectors that were either top or bottom, and it wasn't a big deal, but it was just they had to switch out one connector for another, and sometimes you had to have more than one connector on the board and to go top or bottom on it. So it was two different part numbers, whereas on something like FH81, if depending on where the flex was coming from, they could, it really doesn't matter that they've got a top or bottom onto it. It'll go either way onto it. Some of the dimensions here, it's 0.5 pitch. The FPC thickness is a standard 0.3 on there, and it is top and bottom. You can kind of see some of the dimensions here, which aren't too earth-shaking. Again, here in our, some of these have got very high retention for us because of this mechanical lock in them. We've had other questions of going, well, how much more do we get? It's actually, it's quite a bit. As you can see kind of on the illustration or the simple chart here on the right, we're going from, a comparable connector that's non-ZIF or doesn't have the retention feature on it. Our one action does. Generally, it's going to be in that 2.7 Newton range, but then jumping up to like, say, a 24 pin, FH81, it's going all up to, 16 Newtons, which is considerable in this size of connector. And kind of to underscore that, we've had at least one design win with like construction equipment, like bulldozers, backhoes, stuff like that, that they were using, the maker, the manufacturer was actually using 63 series for, gauges and, dials that were in cab there, and they were finding that the vibration and the bumpiness, the connectors were standing up to that type of an environment. So that 16 Newtons is, really, it's a big number on it, and it's a key selling point. Some competitive analysis here, again, more company 1, company 2, company 3. You can see we've got better height or a lower height, 1.0. Some of our depth is smaller. And we also have a dual contact on their top and bottom. So it's a benefit to any of the other competitors on there. So you can see kind of Hirose does have the edge in those regards on that. Success story here. It was a kind of a notebook PC maker that had that. They had a issue where they were having problems with the assembly workers putting the connector or the flex in correctly, and they were finding they were getting a lot of human error on it, and they could not eliminate the human error on it. Switched. They went to the one action lock. They are trying to now move to the robotic assembly on it, and the connector that we did have on some of this that we designed in there checked all the boxes there. It got rid of the error or the rework or the, the disgruntled customer type thing, that something wasn't right on it and they had to return it. So there was goodwill that was increased on it. And plus they were, they were able to do it in an automatic assembly type stuff. So these are some real world design ins, and they're actually being used in the real world out there. On some of this, you might say, well, how do you do this automatic? Well, they've got, and this actually video, we can play the video, but I'm not. But so the photo on the right-hand side is from a Hirose private show that we do every couple of years in Japan. And this is where we actually had it set up with robotic arms that are going over and getting the flex circuit, picking it up and going and putting it, into the flex connector itself. And this is on the show floor, so you can kind of see how it works. So again, if customers want to run dark, they want to do manufacturing through the thing, maybe they run a day shift and a night shift with, maybe automated going through the night, and, human workers going through the day, they can do it. It's however they want to do it. But the benefit here, or the takeaway, is that a lot of the FH connectors can be done, or one action locks can all be done automatically on this. Some simple specifications here. Again, this can be found. We can send you this if you don't have it. I'm not going to get into it, but applications examples. The applications are almost unlimited on a lot of this stuff, but anything that you can see that's got a display on it is kind of maybe a good space that you can do it. But, we have had that one laptop or notebook PC customer use it. So laptops and small handheld devices, gaming stuff, portable medical. So think like maybe, blood glucose monitors could use these. Any of your virtual reality or assistant reality type glasses. Consumer electronics, a lot of this stuff is really tiny. And, nobody wants a big ice chest size speaker when you can get kind of a little Bluetooth speaker to give, even some of the, maybe a shoebox size Bluetooth speaker can actually really give you really good sound out there. But the thing there is that you're dealing with much more confined spaces than, the much bigger speakers that, they had in the past. So again, everything is going smaller. Hirose has got those types of connectors for those smaller spaces. They're not necessarily limited this stuff, but robotics, 3D printers, a lot of industrial applications, POS terminals, a lot of handheld industrial barcode scanners might be a good place for this, where stuff might be getting dropped, and since the retention force is so good with the Hirose One Action series, something's not going to just kind of wiggle its way out over time or something, and now the scanner's not working, we got to send it back. It gives the manufacturer the insurance that the connector, that it's not going to fail because of the Hirose connector on there with the flex coming out of it. So, but again, anytime you get it's going to be a good place of going, maybe we can get some Hirose, flex circuits in here. Do not overlook the possibility of using a flex circuit as a board-to-board. A lot of the times I would have to say maybe 90% of the times we're always saying a flex connector being used with a display. But, they can be used like as a board-to-board connector. You put a flex connector on one board, route the flex up to the next board, and put another flex connector on that top board, and kind of maybe in a U shape, you kind of got to bend that flex up around, but you can get it, so they can be used in a board-to-board application. And some of the stuff with like FH63S and the FH67, where you've got a right angle and a vertical, it might make a lot of sense to where you can kind of come off of course, the customer would have to have a board type of a setup where maybe there's kind of a right angle, or maybe the board configuration is where they got to come straight up off of the board, but then they kind of bend into the board above it. So we've got that ability to be able to do that. But so don't overlook flex connectors to being used as a board-to-board connector. Using it might be open up some real creative ways the customer can get their needs or their application completed with it. some of the example customers to kind of look at some of this stuff, you know, Dell, Lenovo, Razer. You can kind of see some of these customers here, you know, portable med. Yeah, this could probably be stuff both in, you know, clinical type stuff, more of an in-hospital or a doctor's office setting, but it's also going to be going, you know, into, you know, regular, you know, consumer type stuff. Like I mentioned, the blood glucose monitors or, you know, blood pressure cuffs, stuff like that could definitely, you know, for home use, are going to be good examples of where, you know, you can find a design win on these. So kind of wrapping up on these, the FH81 or connectors, we have both the Hirose has the traditional back flip, front flip, got to open the actuator, put the flex in, close the actuator. We also have the one action offering for customers that want some of that more advanced features on it. We do have a very large number of flex connectors. Like I said, I think Pete had pegged it at 756. Again, that's not 756 series, but there's 700. And so there might be like a, you know, a 10, 12, 14, 16, 18, 24, 26. So it's basically everything, but it's still at 750 individual pieces. It's quite an offering for that. And Hirose kind of invented a lot of the front flip actuator. This is going back probably before I was with Hirose, and that was 1997. We had already FH12 and some of the FH10 stuff. So, you know, probably going back into the early 90s that we started doing some of that. And some of the stuff I should mention, it's kind of a Hirose trivia, but typically anytime the numbering system does go sequentially onto it. So, and we actually did have a Hirose, there was an FH1 at one time, and it was kind of a ZIF style connector that, actually, excuse me, it was not a ZIF, it was a LIF, and it was like a 1.25 millimeter pitch, which just by today's standards is like, it's is so wide, it's almost incomprehensible that we had flex circuits that were that pitch at one time. But literally, you just kind of shoved the thing in through the slot and kind of hoped it held in there type of thing. And that's kind of why they call them a lift connector, a low insertion force, that the terminals actually had to kind of hold on to the flex circuit. And there was issues with that, and so that's kind of why we kind of progressed to, you know, using a zero insertion force or an actuator. But and so right now FH81 is kind of our newest one connector out there. So go out there, find those designs, and good hunting on those. And that's about it. Are there any questions?
Let's see, Chris. I'm
anything in the chat, Pete?
Let's see. I'm checking the chat right now. I did answer one of two questions. A second question on the chat is robotic arm proposal. Whoever asked that question, do you mind elaborating a little bit? Like, are you looking for a Hirose solution for connectors that could go into a robotic arm? Would you mind unmuting and asking the question, please? Well, it's hard to hear you.
Hear me?
Hardly.
Yeah,
You're not very loud.
Specifically, if you had specific proposal for
So on our website, we do have how Hirose can help enable today and next generation humanoid robots. So specific to the arm, not yet, but for the entire system, yes. If you would go on our website, we do have our solutions for humanoid robots. Okay, let's see, that does it. Hey, Chris, that does it for questions in the chat. But before we end the Teams meeting here, let me open it up. Does anyone else have any questions for Chris or the Hirose team here? All right. Well, as Chris showed in his second to last slide, this information will be posted on to Hirose's extranet by the end of the day today. Left-hand portion of this slide here. Thank you, Chris. And also on that extranet are other NPI one-pagers for the latest NPIs that we have released to market, as well as those application system diagrams and such, what Chris referred to as a door opener. So please, if you haven't explored our extranet for some time, please re-explore, because there's a lot of good stuff that can help you get armed and even more dangerous for your customer visits. So we thank you so much for your time and attention today. And as Chris mentioned, happy hunting with the Hirose One action, as well as the new NPI, the FH81. And we look forward to your participation next month in April. Take care, everybody.